Good morning, Honors Pre-Calculus. Go ahead and have out something to do our warm-up problem, our problem of the day. This can be in your homework or it can be in your notes somewhere. A little reminder about homework. I am still taking daily homework grades. I know I have not been there the past couple days to check off your homework assignments, which means I will have to look at multiple assignments at once. So make sure you are keeping your homework nice and organized. And if you're having questions, you seek out some help, whether from me or from a peer. And make sure you have them ready to show me for when I do ask for them. So your warm-up problem is, I want you to algebraically prove whether this function is odd, even, or neither. So I want you to take f of x, and I want you to determine whether this is odd, even, or neither. Hopefully in your work, you are doing something with these three expressions. Okay, I'm going to go ahead and start going through this problem. So as a class, if you think you need a little bit more time, go ahead and press pause. Otherwise, I'm going to go through what I expect to see in this problem. Okay, so first of all, if we have an even function, we need to compare f of x and f of negative x. So f of x is just the function that was given. F of negative x means we're taking a negative x and replacing that anywhere we see an x. Okay, make sure, you do this using parentheses to make sure you can get the proper order of operations. Okay, so when we go ahead and throw that negative x in, we get 2x squared plus 3x plus 1. In order to determine if a function is even, we need to compare f of x and f of negative x. Okay, with this comparison that I see, they are not equal. And since they are not equal, then we can determine that these two are not, or this function itself is not even. Okay. Then we need to move forward with negative f of x. When we look at the algebra for negative f of x, we're going to take our function that was given. We're going to put parentheses around it and a negative on the outside. So then what we'll need to do is distribute that negative through. So we have negative 2x squared plus 3x minus 1. Now for odd, we need to compare f of negative x with negative f of x. Okay, and how do these two compare? F of negative x is not the same as negative f of x, which means that this function is not odd either. So our answer is neither. This is not odd, this is not even. Okay, now our answer is neither, but that's not all I'm looking for. I want to see all of this algebra in order for you to determine that that is neither. Okay, so I want to kind of tell you what I'm looking for in case a problem like this would happen to be on your quiz this Friday or your test next Friday. Okay, I am looking for the algebra. So you're always going to have the given information. I need to see the algebra, so the plugging in and the simplifying for f of negative x. If the function is even, you would not go to this third set of algebra. But if it's not even, I would need to see the algebra for negative f of x. So the setup and the simplifying. Then I need to see comparisons. I need to see that you compare f of x and f of negative x. If they're not equal, well, I guess let me back up. If they are equal, you can determine that they are even. If they are not equal, then I better see this comparison right here. F of negative x and f of x. If they're equal, then it's odd. If they're not equal, then we've done all this algebra just to show that it's neither. But all of that is what I'm looking for, and there'll be multiple points awarded for each of those steps. Okay. Now, I wanted to take a look at one of your homework problems because I was thinking that maybe you would want to know what the answer to this even problem was, and maybe there was some algebra that you weren't really sure about and there was no way for you to check it. Okay. So, here we go. This is the same kind of problem we did in our warm-up. Is it odd, even, or neither? So there's f of x. Let's go ahead and look at f of negative x. Make sure you substitute using parentheses, and it looks like negative x, the quantity cube. Since we have negative to an odd power, it's going to stay negative. But then negative 5 times negative x would be 5x. All right, so here we have f of x and f of negative x. It looks like those are not equal. So we know that this is not an even function. Okay, now we need to look at negative f of x. So I'm going to write our function, throw it in parentheses with a negative out in front. When we distribute that, we have negative x cubed plus 5x. Now if we look at f of negative x and negative f of x, those look the same. So I'm going to write this, that since these are equal, then it's an odd function. Okay. Okay. Also in your homework, I know that there are some problems that you were not able to do, and I told you not to do some of them, right? I told you not to worry about the graphing calculator ones for minimums and maximums. So numbers 47 to 51 odd, you do not need to do those problems. Now, number 97, it did reference a graphing calculator. Maybe you started playing around with your graphing calculator, or maybe you got into Desmos.com and graphed those to determine those. But 97, whether you try your graphing calculator or you get into Desmos, you can still do that problem without knowing much about your calculator or not having it in your hand. Okay, you can use Desmos to help you out with that one. Okay. Make sure that when you're doing your homework, you are reaching out with questions, okay, whether it be to a peer, a different teacher, or myself, okay. I know that I've not been there the past couple days, but you can still reach out with questions when you have them, okay. I want to talk about the green sheet very quickly, okay. This is something that I need you to bring ready to go, filled out on Thursday, which is tomorrow. So first of all, this greatest integer function, we're going to talk about that today. So you don't know what that is, but you will hear in a few moments. On the rest of them, this is what I'm looking for. Okay, so for this quadratic function, the graph, I want you to sketch just the basic quadratic function. And then tell me its equation. So f of x, function notation please, equals x squared. Okay, well now let's look at that graph. The domain is all real numbers and the range is 0 to infinity. Okay, when we look at x and y intercepts, it looks like the origin is both the x and the y intercept. It's the only one there is. And then we can look at the symmetry. It looks like we're symmetric about the y-axis, so we know that this is an even function. Okay, tomorrow we're going to work on transformations with these functions. So if you have the graphs and the equations and the range and domain and the x-intercepts, when we start talking about shifting and stretching and reflecting, you'll have this foundation of, okay, I know what it looks like and we can do that quickly. Like I said, we're going to work on the greatest integer function today. So if you keep this piece of paper out, you can fill it out at the end of the class period. Okay, what I'm going to do is I'm going to post my key late tonight so you can check yours with mine, and then you would check yours with mine, and then you'll have it ready to go for when we do our notes. Okay, also remember your graphing calculator is something you need to bring tomorrow because we're going to start playing around with it. Okay, and it'll help us as we rediscover and remember our transformations of functions. Okay, so let's go ahead and continue with our notes. Okay, your homework assignment is fairly short tonight, which should give you some time. Yeah, it looks like 1, 2, 3, 4 problems, people. 4 problems. So I hope that will give you some extra time to finish this green sheet and get your answers checked so you're ready for tomorrow. Okay, so we're going to talk about piecewise functions, okay? And a piecewise function, the name kind of hints at it, all right? So it's a set of functions where each covers a separate piece of the domain. So it's a set of functions. Notice down here how we're like linked together with multiple pieces, hence the name piecewise. And each of them has a separate domain. So notice how each equation has something off to the side. That's telling you what piece of the domain. Okay, so this is an example of a piecewise function, and we'll do 2 of them, okay? So you'll notice that we're given a function and a piece of a domain. We're given a second function and a piece of the domain. And we could have 3, 4, 5, 6, 7, as many functions as we want to piece together. But we break up the domain so that when you smash all of the domains together, it's the same as all real numbers. Okay, so let's start with this piece right here. And I'm going to put a little orange dot by it because that's going to be my orange piece. Okay, what we're going to do is we're going to make an XY table for the piece 2x plus 3. Okay, this is going to tell us how to fill out the table. We are going to start at 1, and it says the x's get smaller. So we are going to get smaller with our x's. And really, as soon as you have 3 coordinates, that should give you enough information to figure out what's going on with your graph, okay? 2x plus 3 is a linear equation, so that's not going to take a lot for us to be able to recognize, okay? We know it's a line. So now we're going to plug these coordinates into our piece. So 2x plus 3. When I plug 1 into x for 2x plus 3, we get 5. Okay. When I plug 0, we get 3. When I plug -1 into 2x plus 3, we get 1. So what's happening is we are starting at this 1, 5 coordinate. I will connect my line, but it's not going to go, it's not going to go any further than that coordinate 1, 5. Our domain begins at 1 and gets smaller. So I don't need to worry about the line that's over here because it stops at 1. I only have x coordinates that are smaller than 1. Okay, I'm going to do this next piece in this dark purple color. Okay, now I know that our domain for this piece, -x plus 4, is x is greater than 1. I know that we are not going to include 1, but we still need to use that number. So 1 is where we're going to start our domain. And since it's not including 1, I'm going to remind myself that this is going to need to be an open coordinate. Okay, and since we have x is greater than 1, we will get bigger with our x's. Okay. So now I'm going to plug these into this -x plus 4. So when I plug 1 into -x plus 4, we would get 3. So we have an open circle at 1, 3. When I plug 2 in, we get 2. And these are all going to be closed circles. It's only the one that's not included. And then when we plug 3 into -x plus 4, we get 1. Okay, so now I'm going to connect these coordinates for that piece. So you can see we still have a function. It passes the vertical line test at any point. The domain ends up being all real numbers because of the overlap of the 2. Our range looks like we max out here at 1, 2, 3, at y equals 5, and we have everything underneath. Okay. So let's review what I did here. I made a separate XY chart for each piece. This orange piece, I started at 1 and got smaller because the x is less than or equal to 1. This purple piece, I started at 1 with my XY chart and got bigger because x is greater than 1. Since there was no equality, I had to make an open circle on the coordinate for x is 1. And then we connected the pieces from there. Okay. Should we do another example? Go ahead and write down this one. Okay, so we have 3 pieces, so we're going to need 3 XY charts. Okay, so this first piece is x plus 3, and it looks like our domain is x is less than -2. So we're going to start at -2. I'm going to remind myself that we're going to need an open circle there because of the strict inequality, and we're going to have to get smaller with our pieces, or our x's, excuse me. So when we plug these x values into x plus 3, -2 plugged into x plus 3 would be 1. When I plug in -3, we get 0. We plug in -4, we would get -1. Okay, x plus 3 is a linear equation, so keep that in mind as we're connecting the dots here. Here is that piece. How about we do purple for our second piece? Okay, so our second piece, it looks like we're going to go from -2 to 1. Okay, now I said you only need 3 coordinates to get the idea of the shape, but since this one, we need the end points. So if you wanted to leave off one of the middle points, that's fine, but we need the end points to make sure that we're starting and stopping this piece at the right place. Okay, so we're plugging this into x squared. When we plug -2 into x squared, we get 4. Okay, -2 has equality, so we can put an open circle there. 1 does not have equality, so I'm going to remind myself that that's going to need an open circle. Okay, when we plug in -1 to x squared, we would get 1. When we plug in 0, we get 0. And when we plug in 1, we get 1. Okay. So we know that x squared is our parent function parabola. So that should look familiar to us as we connect those coordinates. Just make sure that 1, 1 is an open circle because of this inequality right here. Okay. Last but not least, we have another line. That's nice, right? -x plus 2. We're going to start at 1, and it looks like our domain gets bigger. So when we plug in to when we plug in to -x plus 2, when we plug in 1, we would get 1. Now, when I graph 1, 1, we fill in that open circle. So those two are at the same spot, but they overlap to be a coordinate, and that's fine. That will happen sometimes. The open circle and the closed circle overlap to be just one coordinate, so they connect. Okay. When we plug in 2, we get 0. And when we plug in 3, we get -1. So I can connect those to make this line, and here's our piecewise function. Okay. So if I remember right, you have 2 or 3, I think 2 piecewise functions to graph in your notes, in your homework. Please make sure you're checking your answers to make sure that your pieces look the same. Make sure also that your function is passing the vertical line test. If it does not, you've done something wrong. These are piecewise functions. They all will pass the vertical line test. Okay. All right, here it is, the greatest integer function. This is this weird notation here. It looks like double absolute value bars. That's not what it is. It's the greatest integer function. It has nothing to do with an absolute value, but it has those vertical bars, just double, similar to the bars of an absolute value. Okay, what does this look like to you? Some people like to call this the stair function because it looks like stairs. Okay, what's happening is we have a closed circle at the, a closed coordinate at the origin. We have a stair all the way until 1, 0. Then we hop up to y equals 1 for a stair. We have an open coordinate at 2, 1, and then we hop up to 2, 2. Okay, so we have these little stairs that are just 1 unit in length. Okay, what the greatest integer function is, and I guess let's talk about this first. On your green sheet, don't worry about the range of this function. It's kind of messy to notate. Basically, the range is each integer, right? We have all these little gaps. So the domain's all real numbers, but don't worry about the range, okay? The x-intercepts, there's infinitely many, so you don't need to worry about those either, okay? But this is what the greatest integer function is. The greatest integer function takes the input and the output is going to be the greatest integer less than or equal to x. Okay, so this is what's happening. The greatest integer function less than or equal to x. Essentially, we have to go to the integer that is less than or equal to x. So let me ask you this. What is the integer less than or equal to 3.8? It's 3. The integer less than or equal to 3.8. Okay? If I asked you for the greatest integer less than or equal to 1.2, you would tell me 1. Okay? We're essentially rounding down no matter what that decimal is. Okay? If I asked you for the greatest integer for 1.9999, you would tell me 1, because it's the greatest integer less than or equal to x. Okay, but let's come down here to this example at the bottom. The greatest integer less than or equal to 2 would just be itself, 2. Okay, so if it's an integer, you get to keep it. But if it's not an integer, you need to round down. Okay, so let's think about this in the negative sense. What about the greatest integer less than or equal to negative 1.5? We're rounding down, and in the negative, when we're in the negatives, we have to go down to towards the left on the number line. So that's going to be negative 2. Okay, here's x is negative 1.5. Our y value is there at negative 2. Okay, so you're going to practice evaluating those in your homework also. Okay, so things you need to do tonight. You need to do the 4 problems for your homework. You need to finish the green sheet and check your answers that I will post later tonight. And you need to put your graphing calculator in your backpack